Hey everyone, welcome to DevArchitect. By the end of this video, the viewer should think, I finally understand why our AEM frontend feels fragile and why quick fixes never worked. Most AEM frontend teams think their code base broke because someone wrote bad code. That's almost never true. It broke because the structure couldn't survive scale. And the scary part? Most teams don't realize this until everything feels risky to touch. Today, I'll show you how AEM front-end components actually break at scale and how senior teams structure them so this never happens. First, let me show you the most common way teams structure components and why it quietly fails. This looks clean, one component, everything neatly grouped together. Most tutorials stop right here and say, Great job, this is best practice. But this structure is fragile by design. Why? Because it assumes components live in isolation. Their JavaScript only affects them. Their CSS never leaks. Their dependencies never grow. In enterprise AEM, that assumption is never true. Components are reused across pages. They inherit styles from containers. They evolve over time. And they are touched by multiple teams. What starts as a simple self-contained folder slowly becomes a shared dependency without anyone explicitly designing it that way. And when structure doesn't acknowledge reality, complexity doesn't disappear. It just hides. Now imagine this scenario. 120 components, 4 front-end teams, shared client libs, multiple authors, tight release cycles. Suddenly, one CSS change breaks 5 pages. JS behavior conflicts silently. Nobody knows who owns what. The component didn't fail. The structure did. And this is just the beginning. Let me show you the first silent killer. CSS leakage. CSS never stays inside components. Teams often say, we use BEM, so our CSS is safe. But BEM alone doesn't prevent global overrides, client lib load order issues, author-driven DOM changes. Here's a common scenario. Left side code was written initially. 6 months later, another team writes CSS with the same class name, .cmp dash button, but different assumptions about spacing. The first was designed for one layout, the second for another. Because CSS is global by default, the new style overrides the old one. Now production is broken and nobody knows why. Same class, different assumption. Now production is broken and nobody knows why. Architect insight. CSS is global by default. Treating it as component local is the original sin. This is why enterprise AM projects need architecture, not just naming conventions. So what do teams do when CSS breaks? They add more specificity, add more overrides, add more client libs. At first, each fix works locally, but every quick fix destroys predictability globally. This is how front-end debt compounds invisibly. One small change triggers another. What was a maintainable component yesterday becomes a fragile, brittle mess today. The lesson? Quick fixes are the enemy of scalable CSS. They solve symptoms, not the root problem, the architecture. Now let's talk about JavaScript. Most AEM projects attach JS like shown in the slide. What it does? This selects all elements with the class.cmp-carousel and usually attaches some behavior like a slider. At first, it looks fine. The carousel works, everything seems okay. But problems arise when DOM changes dynamically. Components are nested. Authors duplicate content. Suddenly, your JS runs twice, doesn't run at all, or breaks another component. Architect insight. JS tied to DOM shape is already broken at scale. Just like CSS, logic assumptions that work in a small project fail silently in enterprise AEM. The lesson? JS must be modular, decoupled, and aware of its context, not just attached to a selector. This isn't about CSS or JS, it's about unclear boundaries. At scale, every component needs clear ownership. Who is responsible for changes? Clear responsibility. What the component can and cannot do. Clear contracts. How it interacts with other components. Without these, refactors fail, bugs multiply, and fear grows. So the real issue isn't the technology itself, it's the structure around the components. And this leads to the next question. What does a scalable structure actually look like? Senior teams stop thinking in terms of individual components. They think in layers and responsibilities. If you observe the example structure, notice what's happening. Markup stays simple. Components contain only the HTML structure. Logic is centralized. Shared JS lives in /core/behavior. Styles are layered, not duplicated. Tokens and globals provide consistency, preventing conflicts. Architect insight. Scalability comes from reducing decision points, not adding rules. By separating concerns, not just files, teams create a system where CSS and JS behave predictably. Authors can work safely, and components can evolve without breaking everything else. Ask this question in any AEM project. Who owns the front-end architecture? Often, silence. Without ownership, no refactors succeed, no structure survives, no performance improvements stick. Strong line. Architecture without ownership is just documentation. Ownership isn't a nice to have. It's the foundation that allows components, CSS, and JS to scale safely and predictably. Let's talk about what senior developers notice differently in AEM projects. Junior developers often say, "We'll refactor later." It sounds reasonable. After all, you can always fix it, right? Senior developers hear something very different. "We'll regret this structure later." Why? Because experience teaches them to see the hidden costs. Quick decisions create silent debt. CSS leaks, JS conflicts, fragile components. Refactors in enterprise AEM projects are never simple. One small change can cascade into multiple pages. Ownership, boundaries, and structure matter far more than immediate delivery speed. This is the difference between tactical thinking and strategic thinking. Key takeaway. Experience shows that architecture decisions aren't temporary. What seems small now can create months of debugging, performance issues, and frustrated authors later. In the next video, we'll talk about refactors, why they fail, who breaks them, and why good intentions aren't enough. If this video made you uncomfortable, subscribe. That's how real learning starts.